Hi everyone, today we are going to talk about hash functions. So before we start talking about the details, we need to know how it works. So let's imagine that we have a simple message, which could be, for example, test, let's say, and we are going to put that message to some kind of hash algorithm, which represents the complex, or it doesn't have to be complex, let's say some kind of mathematical operations, and as a result, we are going to get some kind of hash or digest, whatever you like to call it. Below you can see a simple example. We have a string called test or basic text, it doesn't really matter what, and I've put that text through the hash algorithm, and as a result I've got something like this. As you can see, there is a bunch of numbers and letters and so on. So there is one more example. I applied some kind of algorithm to the hashing algorithm to the pretty much similar text. In this context, I've changed only the last letter. I've changed it to upper letter. So as you can see, I've got completely different hash as a result. So in the following slides, I'll explain why it's important to use hashes and why do we even need them and so on. So let's talk about the key characteristics of the hash functions. Hash function should be deterministic, which means that we will always get the same output for the same input. Output size should be fixed, which means that no matter how long the string or text or whatever we are going to hash is long, the result should be always the same size. Avalanche effect, as you probably saw in the previous slide, making the smallest change will result as a completely different hash, so there is no way of guessing how the hash will look like based on small change. Collision resistance. It's very important that we are not going to get exactly the same hash for different inputs. Fast computation. It's very important that a hash function is fast enough, but not too fast, because there is a chance of someone using a brute force attack to guess the original message, which is something that we would like to avoid. It's also very important to mention that hash is not a reversible operation, which means that we cannot get the original message from the hash itself. Use cases. We can use hashing for storing the passwords. So imagine that we have a website, someone is going to enter credentials, password, and so on. Instead of storing the password in plain text, we are going to apply hash function to that original password, and as a result, we are going to get hash. So if our database gets compromised, we are going to leak only the hash values, which are not valuable to the attacker itself. So that's one of the use cases of using the hashing. Speaking of password hashing, it's also worth mentioning two security techniques called salting and peppering. Salting means that we are going to generate random string and append it to the password in this case. For each user, we are going to have unique salt. So as a result, we are going to get unique hashes even if the users have same passwords. We are going to store that salt inside the database alongside with hash of the password with the salt value. So I also mentioned peppering. Peppering is similar concept, but instead of using the different salt, we are going to have one unique long string, which is going to be appended to each password, and we are going to hash it like that. And we are not going to store the pepper inside the database, it's secretly stored at our server side. So hashing is also very helpful speaking of comparison. So imagine that you have a large file and you want to make sure that nobody has changed anything. So you can calculate the hash, and later on you can check if hash changed, because if someone has changed any letter in that file, for example, the hash will be changed and you will be able to see that someone has been playing around with that file and you don't want to use it anymore. Digital signatures. I'll create a separate video for digital signatures, but for now it's enough to know that we can use hashes for digital signatures, verifying the content, and message verification as well. Hashing also found application in blockchain. There are a few more use cases, but I guess this is more than enough for now. There are different implementation of hash functions. They're using different kind of ways for calculating the hash, and I've listed a few of them and we'll go through each of them and explain some important details. MD5 produces a 128-bit hash value, or 32 hexadecimal characters. It was widely used in the past, but its security has been compromised due to its collision vulnerabilities, so it's no longer recommended for application requiring high security levels. SH1 produces a 160-bit hash value, or 40 hexadecimal characters. Like MD5, SH1 has also been found to have collision vulnerabilities, so as a result of that, it's being phased out, so its usage is discouraged in favor of more secure algorithms. Speaking of SH256, this algorithm is widely used, and it produces a hash of 256 bits, as you can guess. So it's, as I mentioned, it's widely used, it's computationally more intensive than MD5 and SH1, which makes it also more secure. So it provides higher level of security in comparison to MD5 and SH1. Speaking of SH3, it was designed to be secure and efficient alternative to SH2 or SH256. So it has support for various output sizes and so on. Blake 2 is a cryptographic hash function that is faster than many other hash algorithms. It also has support for different output sizes and so on. Argon 2 is a memory hard password hashing function designed for securing password storages. So it is considered as one of the most secure choices for password hashing due to its resistance against the GPU and ASIC attacks. So Argon 2 is designed to be computationally intensive, making brute force attacks more difficult and time consuming. So speaking of hashing the passwords, I guess the Argon is the best choice. So when you're about to select the hashing algorithm for your application, it's important to consider a few factors such as security requirements, performance, and compatibility with the existing application. So I guess that will be pretty much it for this video. I hope that you enjoyed and see you in the next one.